Hey everyone, this video is about how to go about converting a fluorescent lamp over so that it can use LED light bulbs. Uh, I'm going to be using these two lamps here. This is a Dazor M209, which has a magnifying glass, and this 2134 over here as part of the discussion. And specifically, this Dazor M209 is the lamp that I'm going to be converting. Now, why would you want to convert from fluorescent to LED? There's a couple of reasons. The first is that fluorescent lights don't always put out enough light, at least in my opinion and in my experience. I wish that this Dazor lamp here put out more light so that I can use the magnifying lens better. I have a little trouble seeing sometimes when I'm trying to magnify things. The second reason is that the lamp could be broken. And now what does that mean? Well, for the most part, it's going to be the ballasts. Fluorescent lights have ballasts, and we'll get into that a little bit later too. But they're not necessarily cheap to replace, at least with factory parts. Like for example, on these two lights here, this lamp has three ballasts because it has three bulbs. This lamp has two ballasts because it has two bulbs. And the ballasts cost somewhere around $50 to $60 a piece. So that's 100 to 180 bucks. That's quite expensive. I could buy almost two lamps for that. So, you know, maybe you don't want to spend that much money on restoring your lamp and you just like to convert it over to LED. So how would you do that? How do you go about doing that? Well, there's, as far as I know, two basic types of LED replacement lamps. There's what's called a plug and play, which is awesome. That's what I would prefer to use. You literally, it's an LED lamp, it's an LED tube, like this one here. It looks very similar to a fluorescent tube, not exactly. It has a circuit board in there, inside, and when you plug it in and turn on the lamp, it knows how to translate the power load coming from the ballast and the outlet plug to work with the LED lamps. If you were to put what's called a ballast bypass bulb in here, it would probably blow up, or at least it would make a lot of noise and not work. So plug and play is easy and great, and I would go there first. Sometimes you can't do that. Like with this lamp here, if you look, we've got three bulbs here, and they're short for one, and smaller too. And I cannot find plug and play bulbs in that size. They don't seem to be available, at least not in the places where I've looked. So I definitely need to convert this over to ballast bypass bulbs. And what that means is that with ballast bypass, you take the ballasts out of the lamp. You don't use them anymore, and you just wire these up basically like a regular light bulb. You have a hot lead going in, and the neutral coming back out through a switch, and that's about it. It is pretty straightforward. It's the wiring on LED ballast bypass is much simpler than what we see in a regular fluorescent light. Uh, One other thing to discuss really quick, because I found it interesting and I don't really hear anybody talk about this much. Why are bulbs called T5 or T8 or T12? This here, that's a T5 bulb. This one here is a T8 bulb, and it has to do with the size, and it has to do with eighths. So all of these lamps, T5, T8, T12, are designated by the diameter of the bulb divided by 8. So in this case, a T5 is 5/8, which is 5/8. That's the diameter of the bulb. In this case, it's a T8, so it's 8/8, which is a 1-inch bulb. And if you were to use a T12 bulb, 12/8 equals 1.5 inches. So T12 is 1.5 inches in diameter. There's probably more to the naming convention than that, but just for sake of being interested, I thought you might be curious to hear about that. All right, well, let's take a closer look at these two lamps here, and then we'll get into the conversion. Let me just show you momentarily how cool these lamps are. I've got this base here. Let's see, that clamps onto the desk. And you've got another location here to pivot it. And then you have this pivot arm here, which is somewhat spring-loaded, but it's balanced with the weight of the lamp, so it'll stay in position when you move it down. And then you have another pivot here, up here, and then another pivot there. It's really a nice working lamp. Before we jump into actually doing the work, I just want to spend a moment talking about safety. Also, skill level needed, and finally, what tools we'll be using. Now, first of all, I am not an electrician. I just like doing projects and fixing things, and this job was pretty easy for me to figure out. And I wanted to show you guys how to do it in case you were interested as well. If you are not confident and comfortable working in electrical circuits, then don't do it. Have somebody else do it for you, a shop, but don't get in over your head. Safety wise also, always make sure that the lamp is unplugged from the wall when you're working on it. There is the potential to touch wires while it's plugged in and get a shock. And yes, I've done that before, and it's very unpleasant. So you don't want to do that. Finally, tools. This is not that bad of a job. We only need 4, maybe 5 tools. You'll see as we're going through the job what's required, but I'll tell you now, you're going to need a flathead screwdriver, some wire cutters, wire strippers, and a soldering iron or a soldering torch. And with those things, you can do pretty much all of this job. The first thing we're going to do is remove this plastic shield. And there are 2 small flathead screws that keep this in place. I always like to use a magnetic bowl that you might get at Harbor Freight or Amazon, just so that I don't lose these things. So I put all of the hardware in the magnetic bowl so it sticks around. Glad to finally get rid of those moths that were sitting in there. And then we're going to take out these bulbs. Before we do anything, let's unplug the lamp from the wall. We don't want to get electrocuted. I don't want anybody to get hurt. Alright, so then we're going to start taking these bulbs out. And we'll save these. These are good bulbs, and who knows, I might get another one of these at some point, and that is untested, and might need to try it out with some bulbs. Alright, the second thing we're going to do is take out the shield. I guess it's not really a shield. The next thing we're going to do is take out the reflector. Again, there's 2 screws right here. And we'll set this aside. And after we get it all, you can see there's some dust and dirt on here, so we're going to clean all this stuff up before we put it back together. And now we can see the intimidating mess under here of wires that we need to start to reorganize. But before we do that, we're actually going to move down to the bottom of the lamp and work on the ballasts. Alright, let's turn our attention to the ballast. So the ballasts are hidden behind here. Now, this is actually the first time I've taken apart this lamp, or any lamp like this. We've got 2 screws on either side. Remove this cap cover, and now we're exposing the ballast. So that comes out. Let's just set it in there. And there's another one on the other side which you guys can't see, but it's going to be essentially identical, I think. I don't know for sure, having not been in here before. And then this paper comes out, and we're left with a bunch of wires and 3 ballasts. And I'm going to make a wiring diagram for you guys so you can see how this works with the ballasts and what we're going to end up without the ballasts.
Let's start looking at some wiring diagrams. Now I have a few to share with you, but we're going to start with the simple fluorescent lamp wiring diagram so you can understand how the circuit works before we make the changes to use the Ballast Bypass LED bulb. The heart of the fluorescent lamp is the fluorescent bulb, and it's made up of various components. It's a sealed glass tube, and inside of the tube, on the inside surface of the glass, there's something called a phosphor. That's the white material you see. And a phosphor will give off light when exposed to radiant energy. Phosphors can be changed to give off different colors of light, but in the case of the standard fluorescent bulb that we use, it's going to be somewhere in the white light spectrum. Daylight, cool light, warm light, and again, that can be changed when the manufacturer puts the phosphor into the bulb. Inside of the tube also is some argon gas and a very, very small amount of mercury. And the mercury goes back and forth between a gas and a liquid. And we have a filament at either end, which is controlled by the electricity coming in here and coming in here. And then later, the circuit will just go across here. When electricity is sent to those filaments, they start to heat up and release electrons into the bulb, and also ions. And the electrons and the ions bombard the mercury, and they excite the mercury, and then it goes from an excited to an unexcited phase. And in that's how the UV light waves are created. So that excitation creates the UV rays. The UV rays then go to the phosphor, and the phosphor ultimately releases the white light that we can see. You cannot see an ultraviolet rays. Humans cannot see an ultraviolet ray. So how does the circuit work then? Let's talk about the whole thing overall. We started with the bulb. We have a tombstone in either end, and that's where the light bulb is plugged into the circuit. We have an on-off switch that is actually made up of 2 types of switches. There's a momentary switch and a constant on switch. So momentary means that as long as you're pushing down on the button, it stays on. But once you release it, it turns off. So there's that momentary and also a constant on-off switch. We have a plug here, and then finally, this is where it plugs into the wall. And finally, we have the ballast over here, and we'll talk about its purpose in the circuit in a moment. So if you'll recall, when you turn on a fluorescent lamp, what happens? Initially, you hold down the button, And if you look at the bulbs, you'll see the fluorescent bulb, you'll see that the two ends glow. And then once you release the button, the entire bulb will light up. So how does that occur? All right, so electricity is always coming to here and stopping. Once you push the button and hold it down, then electricity continues up through here into the tombstone. It starts to run through this filament, lighting the filament and creating energy, continues through this starter circuit, which is created by the momentary on, continues to the other side of the bulb to this filament, out through the tombstone, through the ballast, and back down to the plug again. So we hold down the button, it's doing this circuit, which is causing the ends to glow, and light is starting to be created as the mercury is excited and emitting UV rays, which go through the phosphor, creating white light that we can see. When you release the button, this circuit is closed. Now this circuit is still going to be open because it's constantly on this outside circuit, but the inside one is now turned off. When that happens, the ballast releases a high voltage current which travels up through to the bulb. And recall, this is an AC circuit, so electricity is running from the hot lead to the neutral, and the neutral to hot lead, it switches back and forth 60 times per second. So the ballast releases this high voltage current up here, and since electricity no longer can go through the starter circuit, it arcs from here over to here and remains on, and that current is continually going as long as the electricity is on. And again, in the same way that these two small filaments initially cause the mercury to release UV rays to light up the phosphor, this larger arc does that as well. And that's why then the whole bulb appears white, and it gives off white light, because now the entire length of the bulb, it has ions and electrons releasing UV rays, and again interacting with the phosphor to give off the white light. Now when you press the off button, it closes this circuit and simply turns off the light. Now there's one other thing. So the ballast we talked about earlier, the ballast is responsible for kicking off this larger arc across the bulb. Fluorescent bulbs would, without being restricted, would continue to have increased current flowing across the bulb. It's like a positive feedback loop. So if you don't limit the current going across the bulb, it will run away. So the ballast's second job is to limit the amount of current that goes across a fluorescent bulb so that it doesn't burn itself out. Okay, and after that, again, you hit the off switch and it kills the entire circuit and turns off the light.
All right, let's try to take a closer look at what's going on in here and see if we can decipher how this works. Again, these are the ballasts. There's one ballast per light bulb. So what do we've got? He's got blue wires going to the ballasts, all three of them. We've got where the extension cord wire comes in. It's a 3-wire. Green, that's earth ground or safety ground. So this other lamp over here, the 2134, does not have that. So this is a newer lamp when they started requiring safety ground. And then we've got a positive wire or line and neutral. So let's look and see what's going on. All three, okay, we've got all three of these transformers are connected back to the brown wire here. See this one here on the blue, this one here on the blue and brown, and then the third one, oh, I take that back. It goes to yellow. Well, anyways, we're going to take this apart and we're going to remove these ballasts. Don't throw them away. I never, and I'll just mention this while I'm taking this apart, I never throw these things away. And if there's a way to unsolder instead of cutting, or disconnecting wire nuts instead of cutting, I'll do that. I do not like going in there like a crazy person and slashing wires. It just leaves you more headache in the future when you come back and let's say you want to convert this back over to a regular fluorescent light. Okay, so now here you go. We've got these transformers. They've got one line in and one line out. I'm sorry, they're not a transformer, it's a ballast. What we're left with now is 3 wires, red, yellow, and brown, which were connected to the ballasts. So these are going to be your positive leads heading up to the light bulbs. And then we have this black wire here, which also heads up, and this is going to be your ground. We can leave the ground in place. And then here is the green earth, which is connected to the body of the lamp, and we're just going to leave that in place as well. So ultimately what we're going to want to do is we really only need one power lead going up to the lamp, and we will connect that hot power lead to each of the 3 light bulb tombstones, and then we will connect the ground to each of the 3 light bulb tombstones, and only at one end. And that's about it. It's actually quite a bit easier than the wiring that you see on this lamp. Let's start unraveling the mysteries inside of the top of the lamp. So we'll pull these out first and just take a look. Alright, let's follow the wires as they go through the lamp. So again, we've got the 3 power leads coming up, red, yellow, brown, and these are connected to these 3 black wires, which each go to one of the tombstones over on the left. And then from each tombstone is a white wire that goes back. And this is the push button switch. This is what the underside of the push button switch looks like. And the way this works is that these pairs, top, bottom, top, bottom, top, bottom, and top, bottom, are connected when you turn on the power. Now these white ones are only connected momentarily when you're holding down the button and waiting for the fluorescent light to power up. But this last one here on the very end, this one is full-time power. So these 3 lights, these 3 wires come here from this side, go up through and connect to the other side, to the tombstones on the other side. And finally, these black wires all come back together, connect to the on-off switch part of the switch, the non-fluorescent warm-up part, and then they head back down to the base. So in our case, we don't need all this stuff. We don't need this side other than the tombstones. The way these bypass bulbs work is that there are connectors on both sides, but you only need one side. So one is going to be power and one is going to be ground. So we can
disconnect this side completely from the switch. We can disconnect these white wires from the switch. And then what we're going to do is connect the 3 white wires, which are going to be our ground, back to this black wire, which ultimately goes back down to the bottom of the lamp and ends up going to the ground in the plug in the wall.
Let's now look at the before and after on this simple wiring diagram. And before and after, I mean the before is the simple fluorescent wiring diagram on the left side, and on the right side we have the simple bypass LED wiring diagram. Now recall I mentioned at some point that these LED bulbs are like a simple incandescent filament style light bulb in that they have current coming in on one side, leaving through the same side through neutral, and that's pretty much it. None of this extra circuitry over here is needed for the LED bulb. So, in the first thing that then we would do in making this conversion is that we remove the ballast completely, and that comes out of our neutral wire. And then we don't need this part of the circuit on the right side anymore. So we disconnect that from the system as well. And what we're left with is the 120 volt wire coming in. It goes through the switch, and only the on-off portion of the switch is used, not the momentary portion. That's not used anymore. It comes through, goes to one side of the tombstone to deliver current, goes into the bulb, lights the light, comes back out through the tombstone, and connects up to the neutral side of the plug. And earth will just be here, and that's we're not going to have to change that at all. Now I want to stop and mention here that earlier in the presentation and later on as well, I continually have referenced that the ballast was on the 120 volt side. I was incorrect about that. I didn't realize that until I did some research. So on certain occasions in the following video, in the remainder of the video, I will say something like the positive lead, red, yellow, and brown, are connected up to the light bulb. And what I should have said was that was the ground side. The red, yellow, and brown wires are the ground side. So I've annotated this throughout the video presentation when I've made that mistake. I also went back and shot some additional footage where I was able to correct the error in certain parts, but I wasn't able to completely reshoot all the video. So just keep that in mind. The red, yellow, and brown wires in the video in the lamp are the neutral side of the circuit, and the black wire is the 120 volt lead in the circuit. Finally, I just want to add that I am making available to you guys in the notes below a link to the wiring diagrams I've used in this presentation. So the prior to wiring diagrams that I use that discuss the simple fluorescent light circuit and then the conversion over to bypass LED, they're in the document, and then also this more comprehensive wiring diagram that's for a 3-bulb Dazor lamp. This is the Dazor M209, and it's essentially identical to the prior to wiring diagrams, the fluorescent side on the left and the LED conversion on the right, except that in this case there's 3 light bulbs instead of one light bulb. But other than that, they're essentially the same. So again, look for that in the notes below, a single document that will contain all of these wiring diagrams.
All right, let's start with our rewiring. First thing we're going to do is remove these soldered wires from the bottom of the switch, the three white ones, which are ultimately going to be our ground. So I've got my soldering iron cranked up to full heat. Actually, it's not, now it is. And I'm going to hold it here on this blob of solder until it melts. Now, waiting for solder to melt is just about as fun as waiting for paint to dry. Alright, it helps if the torch is on and not just blowing gas. Let's try this again. There we go. Okay, there's one. As I mentioned earlier, or maybe I didn't, we could cut this, but I hate cutting wires and leaving crap connected to switches, so I'd rather just take the extra few moments to unsolder this and do it cleanly. Okay. There's two. There's three. You know, just to be clear, if you don't have a soldering iron, you don't feel like you want to solder or desolder those joints, you can cut them off. There is nothing wrong with that.
Just know that I will be silently judging you from up here atop my pedestal.
All right, the next thing that we're going to do is connect these tombstones, which are still going to be live, to ground. So this side has been almost completely disconnected except for this one wire here that leads back to the switch. The white wires here are pretty much terminated at the switch because there's nothing connected on the other end. The blacks all come to here. So let's just cut that off. I know I said I don't want to cut things, but in this case I can't get this crimp off, and I'd rather just leave these all together. So I'm going to cut this here and tuck this aside. All right, so let's take these and start twisting them together. Okay, I'm starting to twist them around. We've got all four. Well, thought we did. Okay, let's get this one in there. There we go. Then we're going to take this wire nut. It's a little bit larger than the other ones. That can easily hold 4 wires and get it on there. This is what your lamp should look like after converting the top portion of the lamp over for an LED light. These black wires for the right side tombstones are no longer used. The white wires still connect over to the switch, but they're not being used either. So let's follow the power as it comes up from the lamp base, and then we can walk through what wires are connected how. So the black wire here is coming up from the base. This is the 120 volt lead. It's connected as it was from the factory through a wire nut and then over to the switch. It comes out the back of the switch and connects over here to these 3 white wires, which deliver 120 volt power to each of the 3 tombstones. And that's where the power is being used by the lamps. Afterwards, so the neutral side, I guess, of the lamp is these 3 black wires coming out. They come back out, and I use the existing wire so they connect to one to the brown, one to the brown, one to the red, and one to the yellow. And then these lamps, these wires travel back down to the base. And that's pretty much it. Power in through the switch to the tombstones, back to the leads, down to the base. Now we get to go through the fiddly and frustrating exercise of trying to jam all this back in here and reinstall the reflector and the light bulbs and the cover. So for the moment I'm going to leave the camera running, but I may shut it down. Just going to clean the reflector with some Windex, and that's doing the trick. A little bit more. Just using Windex because it's not super aggressive. I think this reflector would stand up to something more aggressive, but no need to risk it. Alright, so let's put this reflector back up here. That looks right. Yep. Grab one of the screws. Get that in there. Hold your breath. Hope that I don't shake and the screw falls out. Okay, I actually got it. Thank God. Now the other side. Let's try it again. This will probably become an exercise in fast forward. Oh, come on. There we go. Get it started, hopefully. Yep. Okay, and then just make sure everything looks centered left to right. Okay, and then this is tightened up. All right. Now we're going to finish up with the last piece of wiring. We're just going to connect the wires coming in from on the plug, from the plug, into the wires that eventually lead up to the top of the lamp. So we've got a couple sets of wires. The red, yellow, and brown again are going to be our neutral wires coming down from the top. This black here is the neutral wire coming out of the plug. We've got a green wire here, which is earth, and these black wires here are the positive 120 volt coming out of the wall. So luckily the 120 volt is already connected from the factory and we don't have to touch anything. The green is also connected to the frame of the lamp and we don't need to touch anything there. So really all we need to do is connect these three neutral wires to the neutral plug wire and we're done with this step. So let's twist these up. I'll get these three started and add the one from the plug. Give them a good twist. It's a good idea to give these a twist before you put on the wire nut. All right, and then when that's on, keep turning it until it feels tight. Okay, and with that now we should be able to test the lamp to see if it works. All right, off camera, I installed the 3 light bulbs and I put back on the clear plastic cover. So let's plug it in and see what happens. Voila. All right, all 3 are working. Now, the question is that brighter than it was before? Turn it off. I don't know. Seems like there might be a little bit of an improvement. All right, the last thing we need to do is put the base back together. So what I like to do in this situation is store the parts with the lamp. So I'm just going to take these ballasts and just tuck them into these little cubbies in the lamp. But let's turn it off and unplug it before I do that. Even though it shouldn't be a problem, I don't want to find out the hard way. Okay, so and you don't want to tighten it all the way the first time. You just want to make sure that the second screw can slip into its hole as well before you tighten up the other one completely. If it is out of line and the first one is tightened up all the way, then you may not be able to get things lined up on the other side. And that's true in all kinds of things, whether you're putting together an engine or a motorcycle. Always want to start by putting in the bolts, screws, just a few turns to get things set and sitting so you can work on the rest of it and get the other bolts in there. And then after you get all the bolts started, then you tighten it down. So, that's going to wrap up this video on the conversion from a fluorescent lamp over to LED bulbs in a fluorescent fixture. I think the conversion was successful in spite of what I said earlier about the new lights not being bright enough.
I turned it on again and I looked at it, and I'm actually pretty sure it's a little bit brighter, maybe quite a bit brighter. Here, I'll turn it on here. You can see the difference. And with the fluorescent bulbs, it was hard to see the imprint of the light on my desktop when I turned it on. So this is going to be much better for me working in my shop. I appreciate you guys taking the time to watch this video, and I hope it was helpful. All right, so long everyone.